A ball is kicked at an initial velocity of 25 meters per second at an angle of 30 degrees above the horizontal from a platform that is 10 meters high. Assume air resistance is negligible. So the first thing that I want to do is I want to draw a picture, right? So we have the ground, we have some person here on a platform with a very big head, and they're going to kick the ball up at an angle that is 30 degrees above the horizontal. So now that I have a picture, I want to go ahead and write down the information that I have. So I know that my initial velocity is going to be 25 meters per second. I know that it is kicked at an angle of 30 degrees above the horizontal, and I know that my initial position is going to be at 10 meters. That's because if I have an axis here, right, the ground is y equals to 0, and the top of this platform would be 10 meters. So its initial position is at 10 meters. I can also assume that this ball is going to go through a parabolic trajectory here, right? So it's going to land on the ground, meaning that the final position in the y direction is going to be 0 meters. And that's all the information I have. And it wants us to determine how long does it take for the ball to hit the ground, what is the horizontal distance that the ball travels, and what is the velocity of this ball whenever it hits the ground. So this is going to be a 2D kinematics equation. I know it's 2D kinematics because I have an object with some initial velocity moving off at an angle. So because it's at an angle, I know it's projectile motion. Projectile motion has motion that occurs in the x and y directions, so it's going to be 2D kinematics. Because it's 2D kinematics, I need to write down my kinematic equations. Now that I have my kinematic equations written out, let's see if there's any more information I can pull out. I know that my acceleration in the y direction is negative 9.81 meters per second squared, and I also know that because only gravity is acting on this, my acceleration in the x direction is 0. So now I need to determine what equation I can use to solve for time based off the information I'm given. Because I have more information about the y direction, right? I have the initial position, the final position, and the acceleration in the y direction, and I can find the initial velocity in the y direction. I'm going to want to solve for time using the components of the y direction. So automatically, I know that I can't use equation 4 because it doesn't involve time, and time is what I'm solving for. I don't have final velocity, and I don't have time, so equation 2 isn't going to work. And I don't have a final velocity for this average velocity, and I don't have time for equation 1, so that won't work. I need to use equation 3. So I'm going to write equation 3 using y variables since I'm solving in the y direction. So y final is equal to y initial plus my initial velocity in the y direction times time plus 1/2 acceleration in the y direction times time squared. Already, I can tell that this is going to force me to use the quadratic equation. So I know that I'm going to have to use the quadratic equation because I have time squared, time, and then I do not have time contained in that variable, and this matches the form of the quadratic equation, which is ax squared plus bx plus c is equal to 0. So I'm just going to go ahead and I'm going to rearrange this equation so that it matches this form. This means that I would have 1/2 acceleration in the y direction time squared plus initial velocity in the y direction times time plus y initial is equal to y final. I need to move this y final over to the other side because I need this to be equal to 0. This still doesn't match the form of the quadratic equation though, but I can mess around with this term so that it matches the form of the quadratic equation, right? So a delta y, my change in y, is going to be y final minus y initial. Right now I have y initial minus y final. If I make this a negative delta y, then I get y initial minus y final. So this makes our equation 1/2 acceleration in the y direction times time squared plus my initial velocity in the y direction times time minus delta y. So now I need to identify the a, b, and c parts of this equation. So a is 1/2 acceleration in the y direction, b is going to be my initial velocity in the y direction, and c is going to be negative delta y. It's negative delta y because my quadratic equation has a plus, so I need to pull out that negative sign with the delta y. I'm now going to plug this into our quadratic equation, and just as a reminder, the quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to plug these terms into my quadratic equation there. This will give me that time is equal to negative initial velocity in the y direction plus or minus my square root of the initial velocity in the y direction squared minus 4 times 1/2 acceleration in the y direction times negative delta y all over 2 times 1/2 acceleration in the y direction. So now what I want to do is I want to kind of simplify this a little bit, get rid of my halves, deal with this minus sign here. So this will give me time is equal to negative initial velocity in the y direction plus or minus my initial velocity in the y direction squared minus a negative, that would be plus 4 times 1/2 is 2 acceleration in the y direction times my change in y all over the acceleration in the y direction. Now I can actually start to plug in values. So I know that my change in y is going to be negative 10 meters. That's because I start at 10 meters and I go down to 0. So 0 minus 10, right? Final minus initial is going to give me negative 10 meters. And this makes sense, right? Because my displacement in the y direction is going to be going in the negative direction, so having a negative 10 for my delta y makes sense. My acceleration in the y direction is just gravitational acceleration, so negative 9.81 meters per second squared. I do have an issue here though, and that is I need the y component of my initial velocity. We were given an initial velocity, right? An initial velocity of 25 meters per second, and we were given the angle that this object is moving at. So we need to now use our trig triangles to find the y component, right? This would be our initial velocity, this is our angle, this is the x component, this is the y component. So I can use sine of theta is the y component over the hypotenuse, right, to find what this y component is. So I can rearrange this and I get that my initial velocity in the y direction is going to be equal to that magnitude of my initial velocity times sine of theta. And I'm going to go ahead and solve for this. So my initial velocity in the y direction is going to be 25 sine of 30 degrees. And I get that my initial velocity in the y direction is going to be 12.5 meters per second. So my initial velocity in the y direction is 12.5 meters per second. Now I can plug all of these values into the equation. The next thing I want to do is I'm actually going to do this calculation in a couple of steps. I find that it's, I make less mistakes if I do this in multiple steps, and then if I do make a mistake, it's easier for me to determine where I made the mistake so I don't have to do this all over again. So time is equal to negative 12.5 plus or minus the square root of 156.25 plus 196.2, and this will all be divided by negative 9.81. I'm then going to calculate what's happening with my square root. and I get negative 12.5 plus or minus 18.77 divided by negative 9.81. So now I have two options as to what my solution could be, right? I have that my solution is either negative 12.5 minus 18.77 divided by negative 9.81, or my solution is negative 12.5 plus 18.77 divided by negative 9.81. I should get a really obvious answer here. I should get one solution that is positive and one solution that is negative. Obviously, we can't have negative time, so the solution has to be the positive solution. So I have that time is equal to 3.18, well, let's round it, 19 seconds, or my time is equal to negative 0.64 seconds. Well, we can't have negative time, so the time it takes is going to be 3.19 seconds. Now that we know how long it takes, we need to determine how far this ball travels in the horizontal direction. So I have time, and I want to find delta x. I can't use this fourth equation because I have acceleration times my delta x. If my acceleration in the x direction is 0, that would get rid of the variable that I'm trying to solve for, so I can't use this fourth equation. I cannot use the second equation because that doesn't solve for a change in position, which is what I'm looking for. I cannot easily use the first equation, so I'm going to have to use this third equation again. So, to find how far this object moves in the x direction, I'm going to use that x final is equal to x initial plus the initial velocity in the x direction times time plus 1/2 acceleration in the x direction times time squared. I know that my acceleration in the x direction is 0. I know that it is going to take 3.19 seconds for this ball to stop moving. I have my initial velocity as 25 meters per second at an angle of 30 degrees. So I can use my right triangle again to determine what the initial velocity is in the x direction. I'm going to go ahead and do that. So my initial velocity in the x direction is going to be the magnitude of that initial velocity times cosine of theta, because I'm solving for the x component this time. So that would be that an initial velocity in the x direction is 25 cosine of 30 degrees, and I get that my initial velocity in the x direction is going to be 21.7 meters per second. Now I can just rearrange this equation, right? So if I move my initial position over to the left-hand side, I get that delta x is equal to the initial velocity in the x direction times time plus 1/2 acceleration in the x direction, which is 0, times time squared. So this whole term goes to 0. And my change in position in the x direction is going to be 21.7 times 3.19, and I get that the displacement of the ball is 69.2 meters. The last thing it wants us to determine is what is the ball's velocity just before it hits the ground, and I want the magnitude and directionality. So I'm going to want the magnitude and the angle of this. Right away, I know that because there's no acceleration in the x direction, my velocity in the x direction isn't changing. So I can go ahead and write down that my final velocity in the x direction is going to be this 21.7 meters per second, because by definition, acceleration is a change in velocity over a change in time. If I have an acceleration that is equal to 0, I cannot have a change in velocity here, right? So this would mean that my change in velocity is also equal to 0, meaning that velocity final minus velocity initial is equal to 0. They have to be the same number. So I now need to determine what is the final velocity in the y direction. The easiest equation for me to do this is going to be the second equation here. So I have that my final velocity in the y direction is going to be equal to the initial velocity in the y direction plus the acceleration in the y direction times time. My final velocity in the y direction is going to be 12.5 plus negative 9.81 times that's 3.19 seconds, and we get that the final velocity in the y direction is going to be equal to negative 18.8 meters per second. Now this is my x and y component. I need to find the magnitude and the directionality. So to find the directionality, I can use that theta is equal to the inverse tangent of the y component over the x component. So my theta is going to be equal to the inverse tangent of negative 18.8 divided by 21.7. And we get that theta is negative 40.9 degrees. Now I want to find the magnitude. To find the magnitude, I can use the Pythagorean theorem, right? So the magnitude of this final velocity is going to be equal to the square root of the x component of the final velocity squared plus the y component of the final velocity squared, which will be 21.7 squared plus negative 18.8 squared, and I get that the magnitude of this final velocity is equal to is equal to 28.7 meters per second. Now, I'm confident that this is the correct solution, but let's see if it makes logical sense, right? So I'm going to go back to my picture. I have this guy standing on a platform, kicks a ball. This ball is going to come up, do a parabolic motion. It's going to land on the ground. Now, if I just think about this, through this entire motion, the x component of my velocity is going to be going in the positive direction, right? It doesn't change the entire time. As we get to the end of the range of motion, the y component of this velocity is going to be going downwards. So if I add these together, right, the final velocity in the x direction and some magnitude of final velocity in the y direction, the resultant vector would be coming off at this angle. Now if I draw, right, 0 degrees, 270, 180, 90 degrees, and I have an angle of negative 40.9, I would be moving down from the 0. This would be negative 40.9. This makes sense. This is a logical solution.